Welcome back to the channel, everybody. Today we're going to be addressing a question I see a lot on the groups, and that is, how do I wire up my FAR driver or wire up my controller to my battery and to my motor? How do I connect my throttle up? How do I connect my key switch up? And today we're going to show you that on Tackle That. So first, let's go over each component so you have a better understanding of what you're working with. First, we are going to start with our battery. That is basically the most expensive, biggest investment you guys will make. This battery is about $350. It is a 48 volt, 20 amp hour with a 125 amp discharge. So that means it has 20 amp hours. It could run 1 amp for 20 hours essentially, and then you could discharge 125 amps out of this without overloading the BMS, the battery management system inside. So it's pretty powerful, but it's small and compact, and it's not going to last a long time. Probably get a few hours of runtime out of something like this depending on your usage. The next thing we can talk about is the controller. The controller we're using is a FAR driver, ND72300. So the way that works is ND is just the type of controller. 72 means it's rated for 72 volts, anywhere from 48 to 72 volts. And 300 means it's 300 phase amps. That doesn't mean 300 amps from your battery. The line amps are 100 amps, so it's going to suck 100 amps out of this maximum, and this can handle 125 amps. So that's how you want to match those up. You always want your battery to be able to handle more than your controller is going to suck out of it. Then we have a throttle. Now this is an all-in-one system that you can get, anywhere online. It's got a voltmeter. It's got your throttle, full handle throttle. I do not like the partial handles or the half grips. And also your 3-speed selector. So one would be something like 25%, 50%, and 100%. And then you can configure that in your controller. Then also it will have a key which can turn these on and off. It will not prevent your bike from getting stolen. These little guys can get thrown in the back of a truck, a minivan, or anything, so I highly recommend you also put a AirTag or a GPS on your bike so you will know where it is if somebody takes it. The other thing we have is a MY1020 motor. MY1020 MY1020 is the sizing and the bolt pattern. So it's a standard size motor. This is what they call the plus version. It has the orange wire, and it is from Kunray, which is a high quality motor. This can do 3,000 watts of power at 72 volts, but it also will run fine on 48 volts and even more power as long as you watch the temperature. Now we are gonna, when we do actually install this, we'll put a heat sink on here, and this motor has the white wire, which will be for your temperature sensor. So you can set your controller up to limit the speed once it hits a certain temperature so that you do not blow your motor. All right, so let's talk about connections. Your controller is going to have a lot of connections. You're not going to need to use all these. We'll go over which ones you will need. Your throttle will have 3 conductors for your voltmeter, and it'll have 2 conductors for your switch, and then it'll have 3 conductors for your throttle. Now, a lot of times these components are separated, but you'll still have basically these same things. Voltmeter, your throttle, and your on-off switch. And for your motor, you are going to have your phase wires These are going to connect to the controller in here. And then you have your Hall sensors. So these essentially get all the power, and these provide all the information the controller needs to place or power up or reverse your drive shaft. Now this is a double D sprocket. You can change this from a 25 to a T8F to a 35, whatever you need on your build. There's a lot of variety of different sprockets available called double D. The other thing you will need is your pigtail for your battery connection. So this will connect to your battery, and then this will connect to your controller. So this will be the way of connecting and disconnecting your power from the controller. You also will have a charging port on your battery. Now some batteries have a common port charging where you can run your charger essentially to these leads that are connected up here, or you can have a separate charger like this, where I use something like this and mount it on the outside of the housing of your Razor or your bike, and you can just connect your charger up to this. And then this I would wire up directly to the battery with a connector, so that I don't have to take apart the Razor every time I want to charge the battery. I would have a nice port on the outside of the bike, and these come with a nice weatherproof cover as well. All right, so that's it as far as the overview goes. Let's start connecting this all up and getting it to work. First thing we want to do is take this cover off. It will allow us to get to the terminals for your phase wires and your power wires on your controller. As you can see, you got blue, green, and yellow. That's going to match up with these phase wires here. And then you also have a red and a black, which is also going to be for your battery. So let's connect up all these wires. Now, you might need one of these or need to make one of these, and this is going to be the power wire that your controller is going to need to turn on and off, and I'll show you that in a second. But essentially, you're going to connect that to your power, your positive terminal, and this wire now becomes a positive lead you can use to run to your switch, which will turn your controller on and off. I typically will make my own wires, and I'll connect one to the positive and also to one to the negative with something like this, a terminal block, so I can run all my accessories if I'm running any lights or any other power that I will need from the battery. I'll run to something like this and then run it to a switch, so I can control all those and not have a second battery or a separate battery powering my accessories. All right, so we are all connected. You always want to make sure these are nice and tight. Not all your strength, but you do want these tight. There's a lot of power going through these, and if they're loose, it'll create heat, or it can cause a lot of problems with your setup. All right, the other thing we have from our motor is the Hall sensor. So that is going to connect to our controller's Hall sensor. If this doesn't match up, if you have different connectors, you might have to buy a different connector or cut these off and change your connections accordingly. But you can, I will put links in the description, you can find these connectors online to make sure it matches up nice and easy. Whatever one is not the right connector, just cut that one side off, switch it over to the connector that matches, and connect them up. All right, so this is going to be our positive lead from our power. That's going to go to our controller, so that when we turn this switch, the power from the battery goes through the switch and then back to the controller to turn it on. When we turn it off, it'll take away that power and it will turn this controller off. All right, so for our power, we are going to have a yellow and a blue wire typically for your switch, and it's going to go from that positive to the battery to the switch back to the blue wire, and the blue wire is going to connect up to the orange wire on your controller, and you might have to jiggle it a little bit. There you go. And this is the wire that's going to need the voltage from your battery to turn on. Now the next wire is our throttle. Those are typically green, red, and black. Now the one thing you do want to make sure is that they match up. So we got red, red, green, green, black, black. You can depin these and repin these if you need to. It's easiest on the male side. You literally just take something very small, a very small screwdriver, and you can pull these pins out and move them around however you see fit to make sure that they match. The other thing is make sure they're all the way in there. Some of these sometimes they can pop out and then you will have problems with your setup. The last thing we have is our 3-speed switch. So let's just talk about from the controller first. Essentially, when you have this disconnected, you are running in mode 2. Mode 2 is a disconnected mode. If you want to run in 3 or high, you can use this jumper and it will connect up mode 3. Let's see if we can get it connected here. And now this loop has created connection between the black and the yellow wire. So when we connect the black and yellow wire, it puts the controller in high or 3. Now if we want to have the 3-speed connection to use all 3 different speeds on the fly, we want to have a controller that offers that feature or a separate 3-speed switch, and then we will connect that up to the controller, and this will create basically off or disconnected will be on 2. Anytime we connect the black and blue wire together, we're going to be on mode 1, and if we connect black and yellow up together, it's going to be on mode 3. So that's how you get the 3 different settings. 1, 2, 3. All right, the other thing we will want to connect up to is our Bluetooth adapter. This will allow us to tap into the settings of the controller with our phone. And then you also have a lot of other connectors. You probably will find you won't need these. What they are used for is things like high brake, low brake, if you want to use regen with your braking system to slow the motor down, to slow your bike down. They also have alarm connections. They also have a display connection so that you can connect up a display and get a reading out of your controller. And then there's a variety of other different connections there that you probably will not use. So don't get scared when you see all these different connections. In reality, you're only going to need your Hall sensors, your power connection for your switch, your throttle, and your 3-speed connection if you want to use that. You don't even need to use that if you are, if you don't want any different settings and you just want it to run on high all times, you can just use this jumper and not even worry about a switch. I do recommend it though, because a lot of people are going to jump on your bike, possibly if you let them ride your bike, and they're going to just twist that throttle all the way and loop your bike or crash and not have a great experience. So I highly recommend having the switch. You can get those newbies started on 1 or 2 and they won't damage your bike, and they'll have a lot better experience. Okay, so that is it. We are all connected. We also need to connect up our battery. Now what I always do is make sure everything looks good, everything's tight, nothing moves, and I have everything connected. I double check all the colors, I double check all the connections, everything looks good. Sometimes you'll only get one shot at wiring something the wrong way before you fry something, so it's always a good idea to double check your wiring. Let's go ahead and connect the battery up. Now this has a spark resistor in here, so it's an anti-spark. It's not going to make a spark, but on a lot of builds you're going to see when you connect these, it's going to spark because there's going to be an instant transfer of electricity from the battery into the controller, charging up the capacitors in here. Now this shouldn't be the case, so let's listen. Yeah, no problems there at all. All right, so we have power going to our controller. We also have our power going to our switch. Our switch is off. Let's take this little stuff off there. And when we turn this, we should see the voltage of the battery, letting us know that the system is on and ready to go. Hey, I do know what I'm doing. I haven't charged it yet since it got shipped. Usually they ship them around 50%, so do know when you first get your battery, give it a nice charge before you go and expect to run it a whole lot of time. All right, so I'm actually going to go over some basic troubleshooting if you guys are having any issues, the things that I check. And let's turn our voltmeter on so we can see what we're doing here. And I will test to make sure we got power on our battery. So there we go. We have power, and we know that the battery has a good charge, enough to power this up, and that power is getting to the controller. Now what I also can check is to make sure my connections and my switches are working. So we know power is going in here, and then we can check the other side of the switch and see, which is on the orange side, and see if we're getting power. So we are. All right. So if we turn the switch off and we check this orange wire, we can see it's not getting power. So that is the wire that senses your 12-volt connection and turns things on or off as you connect or disconnect power to it. The other thing you can do is check continuity. So if you switch it over here, when that makes a connection, you know you have continuity. So if maybe you're jiggling your switches and things aren't working right, you can check your connections and see if this wire is connected properly to that wire. So a great way to check continuity and make sure you have solid connections. Okay. All right, so once we download the app here, we're going to load that up on the phone, and we are going to go to the Bluetooth section, and you're going to see this WAN-Q-FOC601 device, which is this, and we're going to hit the connect button, which is a little buggy on my phone, but we will try to do that again. There we go. All right, connected. And then you're gonna see a bound button. Now I've already connected it, but we're gonna hit that button, and it's gonna bound it, which means make the connection that you're the owner of that far driver, and you'll be the sole owner until you unbound it. Now you can only have 3 controllers in your app, so I actually have to go around and bound and unbound as I need to tweak settings. But now that we're connected, you're going to see these received frames. That means we're communicating. It's communicating right now. And of course it kind of crashes every once in a while. So let's go to parameters. We can make some basic setting adjustments here, but what we want to do is open Pro NBLE, and this is going to give you all the nitty-gritty settings. So for the first time, it might be beeping at you. It's not configured properly. What you want to set is your rated voltage. So however many volts your battery is, 48, 60, 72. You put it in there, and then it should automatically change the voltages down here, like overvolt protection, low volt protection, restore, based on that. But you can tweak it further if you want. The other things you want to set is the temperature sensor. So for this motor, it's the KTY84. And then you'll also want to select how many pole pairs. So this has 6 poles or 3 pole pairs. So we'll want to select that there. Now, if we return to simple mode, we go over to graph. We're going to do the auto learn process. So we hit auto learn, enter it in, and you're going to have it start beeping at you. It's ready to auto learn. What that means is we're going to hold the throttle all the way open, the whole process until it's complete. So let's do that. Alright, and it'll beep at you. And it'll also have this check box saying it's nice and complete. And now we should be able to give it some throttle and know it's working. Just like that. Perfect. Okay. Alright, that's a nice quick video for you guys on how to wire up a FAR driver. But the same kind of wires work for most controllers. They're going to have phase wires, hall sensors, on and off switches, 3-speed switches, and then of course your 3 connections for your throttle. Those are the most important ones. They're kind of universal on all the ones that I've seen. So I hope that was helpful. If you want more content like this, please subscribe, hit that like button. It helps with that algorithm. We'll see you on the next one.